Welcome. This is Lesson 9 of Module 1 for Grade 7. In this lesson, we're going to represent proportional relationships with equations. Taking a look at Example 1 in Lesson 9, Jackson and his grandfather constructed a model for a birdhouse. Many of their neighbors offered to buy the birdhouses. Jackson decided that building birdhouses could help him earn money for his summer camp, but he's not sure how long it will take him to finish all the requests for birdhouses. If Jackson can build 7 birdhouses in 5 hours, write an equation that will allow Jackson to calculate the time it will take him to build any given number of birdhouses, assuming he works at a constant rate. In order to write that equation, we need to take a look at the ratio we have and find the value of the ratio, or the constant of proportionality. So our ratio, Jackson can build 7 birdhouses in 5 hours. There's a couple of different equations that we can write. We want one that we could use to find out how long it will take him to build any number of birdhouses. Our first step is to define our variables we're going to use in our equation. We're going to compare birdhouses in hours, so let's use a capital B for the number of birdhouses Jackson can build, and a capital H for the number of hours it takes him to build them. To write an equation, we need to find the constant of proportionality, which is y divided by x. But which number is y and which number is x? We could use either the hours per birdhouse, which would be h divided by b, or the birdhouses per hour, b divided by h. Since we want to know how long it will take him to build any number of birdhouses, we want to use something that will allow us to get the answer in hours. If we used h divided by b, that would be 7 divided by 5, which means Jackson can build 1.4 birdhouses in an hour. b divided by h gives us 5 divided by 7, which means it takes Jackson 71/100ths of an hour to build a birdhouse. So we can write 2 different equations depending on which one of these we use. If we write b equals 7/5 times h, this lets us find the number of birdhouses Jackson can build in an hour, or in h hours. If we use the other direction, we would have h equals 5/7 times b. Notice that we swapped the b and the h, and our constant of proportionality is the inverse, or the reciprocal. This second equation lets us find the number of hours it takes Jackson to build b birdhouses. Let's look at part B. In part B, we want to know how many birdhouses can Jackson build in 40 hours. Since we know the number of hours, let's use the equation birdhouses equals 7/5 times the number of hours. We're going to substitute 40 for h and multiply. So here's our equation. We're going to multiply 7/5 times 40. That's 7 times 40 divided by 5, which is 280 divided by 5, which gives us 56 birdhouses. So in 40 hours, Jackson can build 56 birdhouses. Question C asks us, how long will it take Jackson to build 35 birdhouses? In this case, we know how many birdhouses we want to build, and we need to find the time. So we're going to use a different equation. Since we know the number of birdhouses, let's use hours equals 5/7 times the number of birdhouses. We're going to substitute 35 for b and multiply. h equals 5/7 times 35, which is 5 times 35 divided by 7, which is 175 divided by 7, which gives us 27 hours. Part D asks, how long will it take to build 71 birdhouses? If we use the same equation, we can just substitute 71 for b and multiply. That will give us 50.7 hours. Now, it's important to understand whether we can have partial amounts of things. I know we've talked about this before. We can have Jackson work for a part of an hour, like 50 7/10 hours. But he's really not going to be able to sell a birdhouse that's only partially done. So we would want to round birdhouses to the nearest whole if we were doing this equation. Let's look at example 2 to see another example of how we can write an equation to represent a relationship. In example 2, we have a couple of produce stands that sell corn. Al's produce stand sells 6 ears of corn for $1.50. Barbara's produce stand sells 13 ears of corn for $3.12. We want to write two equations, one for each produce stand, that model the relationship between the number of ears of corn sold and the cost. Then we're going to use each equation to help complete the tables. So first, let's think about what we need to write for our constant of proportionality. We have 6 ears of corn for $1.50, or 13 ears of corn for $3.12. Since we really don't want to know how much it costs to buy a partial ear of corn, we need to find the amount of money for 1 ear of corn. So we're going to take the cost divided by the number of ears of corn. Let's do this for each of them individually. We're going to put Al's information on the left and the Barbara's produce stand information on the right. For Al, he can sell $1.50 will buy you 6 ears of corn. If we do that division, we get 25 hundredths, or 1 ear of corn costs 25 cents. For Barbara, she sells 13 ears of corn for $3.12. When we do that division, we get 24 hundredths. That means 1 ear of corn costs 24 cents. If we wanted to write an equation, the cost is going to be the amount for 1 ear of corn times the number of ears of corn. If we use variables for cost and ears of corn, we get the equation C equals 25 hundredths times E. And it's the same for Barbara. Our cost is going to be 24 hundredths times the number of ears of corn, or C equals 24 hundredths times E. Now we don't need to write an equation where we have E equals something. We can substitute for C or E in this equation on either side. Let's fill out the table for Al's produce stand next. If we know that we're going to buy 14 ears of corn, we can substitute 14 in for E and then multiply by 25 cents. And we'll get $3.50. If we want to find how much it costs for 21 ears of corn, we do the same thing, only we substitute 21 for E, and we get $5.25. If we want to spend $50 to find out how many ears of corn we can get, we can substitute $50 for C instead of E. And then we're going to divide both sides by 25 cents and get 200 ears of corn. So $50 will buy you 200 ears of corn. Now let's look at Barbara's produce stand. We have the same number of ears of corn, 14 ears of corn and 21 ears of corn, and we follow the same steps. Substituting 14 for E gives us $3.36. Substituting 21 for E gives us $5.04. At Barbara's stand, we want to know how many ears of corn we can buy for $49.92. If we substitute that in for C, we're going to get 208 ears of corn. Now you can see that it doesn't matter which way we write the equation as long as we understand where the variables go and what our constant of proportionality is representing. Make sure you have all of your notes filled out and bring them to class. and we'll see you then.